So next up, we have Lasya. Lasya, go ahead. Yes, we can see you.
Let me just share my screen.
Mhm.
Okay, can you see my screen?
Yes, please.
Okay, so hi, I'm Lasya, and I'm a sophomore at Lambert High School in Georgia. And my topic was exploring the potential of gene therapy in treating spinal muscular atrophy. So first of all, what is spinal muscular atrophy? So this actually refers to a group of diseases that can damage and kill motor neurons in both the brain and the spinal cord. And it mainly affects infants that are 6 to 18 months of age and causes severe muscle weaknesses and can prevent these children from engaging in basic activities such as just sitting up, standing, crawling, walking. And it's primarily regarded as a genetic disorder because of the mutation in the SMN1 gene, which causes a deficiency in the SMN protein, which is crucial for motor neurons to function. So my main question that I was trying to look into with my research was, what are the most promising gene therapy approaches for treating different types and severities of SMA? So currently, there's really no like straightforward cure, but forms of gene therapy are being looked into, and there's been like clinical trials testing them out. So that's what I'm going to be going into with my research. So one of the first gene therapies that I looked into was called Zolgensma, and it actually prevents further degeneration by replacing the SMN1 gene. And it has been approved by the FDA for pediatric patients with SMA that are less than 2 years old. And first, to begin the gene therapy, some evaluations must be done. For example, first, there must be a confirmation that there is a gene mutation in the SMN1 gene. And also, it has to be confirmed that the patient's health is overall stable and all functions are working properly, such as liver functions and things like that, for the therapy to be for the therapy to begin. And some of the most common adverse reactions with this therapy, which had an incidence of less than 5%, were elevated aminotransferases and vomiting. So aminotransferases are liver enzymes, and when they're elevated, it can cause liver damage. So looking into one of the clinical trials with this gene therapy, it's called the STRIVE trial, and this was a phase 3 trial for symptomatic SMN1 patients who were less than 6 months old, and they were observed until they were 18 months old. And some of the results that I observed were 41% of patients after taking the gene therapy met all three criteria for the ability to thrive at 18 months of age. And so these criteria are like swallowing and tolerating thin liquids, maintaining a weight consistent with their age, so about the third percentile, and they went free of non-oral feeding support. So these are definitely huge milestones for children with this disorder. And additionally, 68% of patients did not need non-invasive ventilatory support during the study, so that they were able to maintain a stable respiratory function. And in this chart, you can see some of the milestones that patients achieved after receiving the therapy. So some of the most common milestones were head control, rolling over, and sitting unsupported for more than 30 seconds. So these seem like very common like milestones that most babies can be able to do by the time they're 18 months old. But unfortunately, a lot of people with these disease are not able to do this. So the gene therapy was definitely successful, and hopefully we can get these milestones more common as the therapy continues to be researched and improved. So another gene therapy that I looked into was called Spinraza, and it actually helps patients with SMA increase the SMN protein, which is crucial for the motor neuron function. They increase the production of that protein by working with the SMN2 gene. So the SMN2 gene is a copy of the SMN1 gene, and it has the same function, but it only makes a little protein. So as you can see here, as the SMN2 gene and the treatment work together, there will be an increased protein production, improving the motor neuron function. So some of the most common side effects of this therapy were lower respiratory infection, fever, and constipation. And one of the clinical trials that I looked into was the ENDEAR study. And this was a study of 121 children that were 7 months old and younger. And they had type 1 SMA, and they were observed over a 13-month study. And some of the results were that 51% of patients treated showed motor milestones. So, as we said before, it was head control, rolling, independent sitting, and standing were some of the main milestones that they achieved. And also, overall, there was a 47% reduction in the risk of mortality or permanent ventilation, kind of showing the success of this gene therapy. So for my methodology, I first started by going over like reviewing reputable sources, and some of the main ones I used were the National Institute of Neurological Disorders and Stroke and the National Library of Medicine. And I next started gathering like information from different research papers, articles, journals, and then another layer of tables, graphs, charts, pictures, and scans, and analyzing them to get my results. And so, for my conclusion, just wanted to go over like my research question again. What was the potential of various gene therapies to treat the range of spinal muscular atrophy phenotypes? So, judging by like all the research and resources that I looked over, I would say that the gene therapies were highly effective in SMA patients because they were able to expand motor and respiratory functions and even survival in patients. However, I think further research should be done on the adverse reactions because some of them are severe. And I think if we improve our research, then these can be minimized more. And some of the limitations of the studies that I looked into were that they didn't account for like advanced SMA patients. So by advanced, I mean like patients that have like full paralysis of their limbs and just very severe symptoms. And some of them also didn't account for other variables that may have impacted the study. So I just wanted to talk about my research experience. So first, I would like to thank Professor Varkey because I learned a lot from his classes about genetics and neuroscience and how they relate to like neurodegenerative disorders. And like in the one-on-one session, he really guided me on exactly how to like gather more information from different sources and kind of project my information well. And for Professor Virgil, he was really helpful because he helped me structure my paper and format it in a way that was easy to understand, but also was made my information more detailed. And he always was encouraging us to take like the extra step with our writing to improve it. And then to Gifted Gabber and Coach Joe, I would just like to thank them for the opportunity to help to write the research paper because this was my first time doing this, and I actually never thought I would be able to write a research paper like this because it was definitely like a long, tedious process, but they really made it a really smooth experience by encouraging us the entire time. So thank you so much.
Wonderful job, Lasya. Excellent topic, excellent depth of research. And thank you. Yeah, Professor Varkey.
Yeah, good job, Lasya. I see that you incorporated a lot from after one-on-one interaction. So, did you read more about like may I know like did you read more about the SMN, like how it actually functions in the cell, the SMN1 protein?
So I just like from the research that I saw, it was just about how it expanded like the motor function for patients. But I
Mhm.
didn't really go like in depth of like exactly how it does that, but I definitely will look more into that.
Oh, yeah, so yeah, that will be something good that you can add as well because I know that you have already gone quite into the depth of with respect to the high school research, but I always want like students to keep on improving on whatever they have built. So since you already have that, maybe you can look into the SMN complex as well and add that mechanistic aspect as well, like how small nuclear ribonuclear proteins, like how it affects the splicing, and that is correlated to the development of mutation and like whatever issues are there. So good job. Continue to expand on whatever good foundation that you've already built on.
Thank you.
Okay, a big round of applause to Lasya. Please, 2 questions. I don't see the questions flowing in the chat. Please ask them in the chat. Your performance in this research is also based on what questions you ask, what you learn from just not your research, but from others as well. So please go ahead and put 2 questions for Lasya.